Okay, hi. In this video, I'm going to record some of the stuff that I wanted to cover on Friday or Thursday when we were having some technical difficulty for my 574 class. The first part of the video, I'm just going to go over the setting up the tools. So basically, these instructions about getting Docker, GitHub, and the Git tools, and the Visual Studio Code with the development containers on there. Okay, I'm not going to show the whole installation. I'm just going to mention a few things about this, and then the second part of the video will get into the important part. I'll show using this environment to run containers, and so you can access the class resources and you can work on the class assignments. All right. So when you're installing Docker from this installer here, you can just accept all the defaults. So the first time you install it, you'll reboot, and then when you reboot back in, what you want to do is Docker desktop might not start up automatically. So if you have to, you need to go in there and find it and start it. So what you want to get to is that the engine is running. Okay, so for this stuff to work, you have to have Docker desktop running, and when you look in here, it should have that engine running, or if it's been running for too long, it'll go into this saver mode. Okay. So most of my Mac people for recent versions haven't been having any problems getting Docker installed. So for Windows, if you're a Windows person, there's two major things that cause a problem. One is mentioned down here in the description. You have to have virtualization turned on in your hardware. So if after rebooting, if you try to run the Docker desktop, if the engine doesn't start, you might need to reboot your system and get into the BIOS. There's some help on trying to do that. And you have to find the BIOS setting for the CPU. Under CPU, there'll usually be a setting like virtualization, and look for either Intel VT or AMD V or something like that, right? And make sure that's enabled, okay? So a lot of people, that's an issue. They don't have that turned on. The other thing is that the Windows subsystem for Linux, WSL2, doesn't get installed, or it takes some time to install, and Docker doesn't always start up the first time you reboot. Okay, so what I suggest is, especially if you get an error, something that's mentioning WSL, open up a command line prompt, and do a WSL --status, and see if you get anything. If you don't get something about the default distribution, you might need to update. Okay, so the first thing I suggest people doing, if the engine isn't able to run, is to do a WSL --update. If it's not up to date, it should install and update it and get everything that you need. And at that point, you probably want to reboot your system and restart the Docker engine and see if it starts up or not. Okay, if it's still not starting up, even though it looks like the update updated your system and it was ready, you can try doing an install of some distribution. So in this case, this would install the most recent Debian distribution. Okay, so install that, and same thing. If it looks like it installs correctly, go ahead and stop Docker and restart it. See if the engine comes up. If it still doesn't come up, reboot your system one more time and then start Docker desktop. Okay? At that point, if you think your WSL is up to date and installed, and if you think you've got your BIOS virtualization settings enabled, but your Docker still doesn't run, we'd have to investigate it more deeply. Okay, but those are the most common issues for Windows people. All right. Moving on. So secondly, you need to have Git tools installed. You need to have a GitHub account created. I suggest doing this first. So open up a terminal on Windows or Mac and see if you have Git already installed. So do a git ---- version. If you're a Windows person, like I'm showing these examples on Windows here. So if you're Windows, you probably won't have Git installed. I already installed them here. If you're Mac, you probably won't have Git installed for recent versions of Mac OS either, but by running Git version, it will pop up and offer you to install, I think, the Xcode development tools that have Git in there, which is probably the best way, is how you want to install your Git on a Mac OS system. On Windows, you do have to get this installer, select all the defaults. Like it says here, the second or third default option on the end on is configuring the line ending conversions. On Windows, make certain that you change that from the default to checkout as is and commit as is. Okay, you can accept all the other defaults, but that one, if you're a Windows person, you should change, or else you'll have problems. Okay, it's not the end of the world if you miss that. I'm going to show you here in a minute how you can fix that after the fact. So you don't have to actually set it when you install. You can set it by just configuring a Git global option here, like we do with the username and stuff. Okay? So once Git is installed, you should be able to run Git version. You should be able to run Git from the command line, like I just did here. So make sure you do these steps. Okay. I didn't show these in the instructions, but you can list out your global Git configuration using git config -- list. So here for Windows people. That characters from line feed thing is only a Windows person issue again, so it won't be a problem on Mac OS or Linux. But so again, you can check on Windows the core.auto_crlf. That should be set to false. If it's not, then you need to configure that. So I'll show that one first. So if you do a git config -- global, then core.auto_crlf to be false. That will configure to be false. So if that was true or unknown or unset, you'd probably want to go ahead and configure it to be false, like I just did here. Right? So if I relist, so I noticed that this, when you set it but from the command line like this, it'll show up twice, but don't worry about that. It'll use the second one. So even if you incorrectly had it true from the install, as long as you set it to false, here on the command line, it'll use the second version of this again. So anyway, don't skip these. You need to also configure username. So use the name that's shown in our gradebook in MyLeo Online. So whatever name is your official name by the university that you see in your gradebooks, you should put that as your name, and git config. Your user.email should be your primary email that you set when you create your GitHub account. So here's my GitHub account. You can check all your settings if you go to the upper right and click on your icon. You can find and set all your settings in GitHub here. All right. So your emails is one of the multiple settings in here, and so this is where you can check. Hopefully you're using your Leo mail, so I encourage you to just use your Leo mail if this is a new GitHub account for you, but it's fine if you already have an existing GitHub account. So, but whatever this is, that needs to be what you set as your global Git configured email address, or else things won't show up correctly when you push commits to GitHub. All right. So again, let's we didn't show this, but let's just list out our configurations just to show you that it set those, right? And it sets those in a file, so even when you reboot, it'll remember those, right? So those should always be set. Your auto_crlf, if you're a Windows person, then your username and user email, okay? And then you need to generate a public-private key pair and get that copied up to GitHub, okay? So run this SSH keygen command. If you're doing things from the command line, spelling and stuff matters, space, punctuation, right? So if you're not used to doing stuff from the command line, you have to be careful about spelling and punctuation and white space and stuff. So I misspelled my command there. So keygen, make certain you select the defaults unless you know what you're doing. So when you run Git in VS Code, it expects your key pairs to be these standard name files. And if it's not, it won't find your keys for you. So you should just hit return. So it uses the ID_RSA, and just don't use a passphrase, again, unless you've done this before, know what passphrases are and how to use them for secure shell keys. Okay. You might, some distributions now default to using ID_ED25519 keys instead of RSA. So you should be aware of that. So to copy this key to your GitHub account, you can just browse to your file system. So it generated this key in my C users quick emu. There's a subdirectory called .ssh, and under there you need the public key. You can also just type it out. So you can use type the type command on Windows systems, or the equivalent on Mac and Linux systems of the cat command. So I could just type out the .ssh id_rsa.pub file to see my public key. Right? So I do that because I want to copy and paste it. So I'm just going to select the whole thing and copy it, and we'll paste it over into our GitHub account. Okay. So again, to add a key, you have to go to your settings, which I already had up here, and find the SSH and GPG keys. Right. And then here you want to create a new SSH key. And then just paste in that public key, whether it was RSA or ED25519 here. It's an authentication key, so leave that. Give a good title. So this is my CSci 574 Windows demo key pair here. All right? Just as an example. All right. So once you've done that, also don't skip this step. It's very important that you test that your authentication of the key is working before you try it out in VS Code. Okay, so what we want to do is do SSH to get at github.com. All right. So what this does is this will look in the .ssh directory for the standard name files and try each of the public keys to see if it can authenticate to GitHub with one of them. So one reason why this is important to do this on the command line is if you did this the first time in VS Code, it will give the same prompt. So the first time when you connect to a site using SSH, you have to authorize that site. You have to tell SSH that, yeah, this is the site I meant to connect to. You might not see that prompt in VS Code. It's kind of hidden. So if you do it here, you'll be guaranteed to see it. So you want to enter yes, that you want to connect to GitHub. That I want to continue connecting. That's the correct site here. So. And you might have to hit return once or twice to get it to finish off and wake up. But that's what you're looking for. You need to successfully authenticate. So if you don't successfully authenticate here, don't move on to the next step. Fix this, get your SSH key into GitHub correctly, get your SSH key generated before you move on. All right. So that's the first two tools that you need. The third one you need is VS Code. I've already got that installed. Again, you can just accept all the defaults. When you run VS Code, you just need one extension to get started for this class. You need the dev containers extension. So I sometimes refer to it as the remote dev containers extension. There's one called like remote containers and one called dev containers, but we really want the dev containers, so don't get confused by that. So the way to add extensions is on the left-hand side. You got various things, tools that you can use, including extensions, which add capabilities to VS Code here. So you might see it as a recommended extension. If you look here, it's the dev containers. If you don't see it, just do a search for dev containers. Dev containers, like that. So it should be the first one. Like I was saying, it doesn't hurt to install the remote development, but that's for doing development on a remote machine over Secure Shell. You need the dev containers for this class. That's for doing development in VS Code inside of a container running on like Docker or something like that on your host, on your same system instead of on some remote system. So just find that and install it. All right, and when it's installed, you should see. Let me clear off my search here. I get annoyed by the popular and the recommended. I often just uncheck those. So anyway, so you need to just have the dev containers to get started. Okay. All right. So in summary, before I move on to the next part, you have to have Docker running. Check that you got it so the engine is running. That has to be running before you can use containers in VS Code. You have to have a GitHub account, and you have to have a secure shell key that can successfully authenticate on GitHub, like that. and you have to have VSCode. Right? It wouldn't hurt to also authenticate your key in VSCode as well. So you can open up a terminal. Let me expand it a little bit here. So your options on your top menu bar, one of them will be terminal. So on your, we're not in a container yet. So on your host system, this will just be running, PowerShell, I think, or on Windows. On Mac, it would just be running like an Xterm or VT100. But you should be able to see the same configuration. Oh, sorry, git config lists that you set up there, and you should be able to do the authentication to GitHub from here as well. All right. Okay, so that's it for the first part. Let's move on to the second part here. Okay, in the second part of this video, this is the main thing that I really wanted to get to, so I'm assuming you've got your tools all set up. So once you have that, you should be able to use the repositories that I give you and the assignment repositories that will be created to you for the assignments to do everything you need to do for this class, all right? So in particular, let's start with the class resources. So there is a repository that has all the lecture notebooks and other resources for the class. So if you go over and look at the additional resources, you'll find a link to it here for the 574 class resources, okay? So this repository, I own this, and I don't give people read-write access to it. So you actually have to clone this using the HTTPS URL. So if you don't open up this repository, select the HTTPS URL. So the difference between these is, the reason why we set up the SSH key is if you clone using the SSH key, it gives you the ability to create commits and push them back. So you can actually modify and create code and put them back into the global repository, right? So you can clone copies using HTTPS, which is kind of like, it's not really read-only. You can download the files and you own the files and you can modify them and run the notebooks and stuff. You just can't make a commit and push it back here. So I don't allow you to change this repository, all right? So, get the HTTPS URL. So back in Visual Studio Code, you should have the dev containers installed like I showed, and you should be able to authenticate. You should already have tested that your secure shell key authenticates correctly from here. So what I normally do to clone a repository is I go to another one of these areas on the left-hand side called the source control and do the clone repository. You can do that in other ways, but that's one way you can get to this. And just paste in either the HTTP URL or the SSH URL of the repository you're cloning in. Select the clone from URL. Don't clone from GitHub. That's something slightly different. So you want to, if you're using a URL, you want to clone from that URL that you paste in there. All right. You have to select a location on your host system, your local system, where you're going to download those files into. I recommend creating a subdirectory called repos that you put your files into. I have lots of repositories, so I usually have subdirectories under my repos. I'm going to put it under my repos CSci 574. Okay, so I'm going to select that as my repository destination. So it's cloning or just downloading all the files now from the repository right now. So the way that Visual Studio Code works is a directory or a folder acts as the top level of a project in VS Code. So that what's asking is we want to open that folder to become the project that we work on in VS Code. And you always want to do that. You always want to open up that cloned repository to become your project folder that you work on here. All right. So when you do this, if you've got your dev containers extension installed and you've got your Docker desktop running and the engine has started and running, you should get a pop-up offering to reopen your folder inside of a development container. Okay, if you don't see that, you don't have the extension or your Docker engine is running or there's some other problem with Docker or your containers. Okay, if you miss that pop-up or you don't see it, when you installed the dev containers extension, it added another thing on the left-hand side called the Remote Explorer, which is the place. I don't know I don't know if that's a great name or not, but this is where you manage your containers. You can also manage your remote connections if you're using the remote development thing. But so all containers that you create should show up here. I had an old one that I forgot to remove that I did before. So when you do this the first time, you probably won't see anything here, right? So it'll probably look like this. Since I missed, you can't just select that button to reopen a container when you see it. Since I missed that, I can just go to my Remote Explorer and open the folder in a container, right? And I'll select that folder that we cloned, right? So remember, I cloned it into my repos 574 class resources subdirectory, right? So now I'm going to reopen this folder in a container. All right. So the first time you do this, this might take some time to do. So I might pause this video or cut out this here. I've done this before. So Docker is setting up this container, so it caches a bunch of stuff. So it's not going to take me as long to do this as it might take you the first time. So it's already cached a bunch of the images and things like that. In fact, it went really quick. So even if you've got the images cached, when it creates the container, it also has to install Python and a bunch of other stuff. So. But I'm actually done now. So I successfully reopened our class resources folder in the container. All right. So now there's a couple ways you can interact with the files in these repositories for the class. So you can look through the file explorer here and see all the subdirectories. We've got like a lectures subdirectory, which has most of the lectures that are mentioned in the different units for our class, and other things, some data and other stuff in here. These containers actually run a Jupyter Lab server for you, and it goes to port 8888. So you might get a pop-up offering to open up a web browser into the Jupyter Lab container. That probably won't work for you because so what I normally do is, if you look in this nohup.out file, if you look near the bottom of the file, you'll see some URLs. So the issue is that for recent versions of Jupyter Lab, by default it creates it with a token, which is kind of like a random generated password. So you need that token in order to log in to Jupyter Lab. So you could just copy that token and open up, or you could just, I usually just control click on this URL. The 127.1 is probably the best one to use. So if you control click on that, it should open up the Jupyter Lab in your default browser, and it gives it that token, that password. So you're actually logged in right away there. All right. So that's basically it. I'll probably show you more later on as this class goes, but in particular, this is the stuff you should have been working on for the first week. So these U01 are the notebooks from the first week that were mentioned about. So you can double click on these about basics of Python, data structures like strings and lists and other dictionaries in Python, and a little bit about functional and object-oriented programming in Python. So those are the notebooks that were mentioned that you should go through as part of learning about the stuff in the first week there. All right. There's other stuff in the class resources, but that's all I'm going to show here for the moment. I also wanted to show getting started on the assignments real quickly. So normally when I'm done working on one of these dev containers, what I normally do is I just do a file. I go to from VSCode. I close the container. So I go to VSCode and do a file close remote connection. Okay, that will actually stop the container relatively cleanly. All right. So when you do that, if I go back to my Jupyter Lab, that Jupyter Lab server has been shut down. So this is no longer valid here. The stuff I was doing in the Jupyter Lab. So, all right. So let's show accepting the assignment and getting started on it, at least for the class here. So if you go to our MyLeo Online, so for each of the assignments, there will be a subunit for the assignment, and you should find an invitation link. That's how you get started on the assignment, is by clicking on the invitation link. I might have already done this. I can't remember, so let me check here. So yeah, I mean, the first time you do that, you'll have to associate it with your name in the grade book, and then after you do that, you'll have to click that yes, I accept the assignment. Then once it does that, what this does though is it creates a repository that you have read-write access to. Okay, so my organization, the 574 Spring 2025 organizations, actually owns the repository, but you can actually create commits and push them or write them back to the repository. So you can click on that to get to your assignment 1 repository. If you close this off, the way that I normally get back to a repository personally is I go to GitHub. You won't find it under repositories, again, because it's not really owned by you. It's owned by my organization for the GitHub Classroom. So you have to go to your organizations, find, you should probably only have one organization, the 574, unless you've been doing GitHub stuff and already joined some other organizations on GitHub. So you should be a member of the 574 Spring 2025 organization. Then if you go to your repositories, once you're under the organization, I see everybody's repository, but you only see your own. So you should only see your assignment 1 repository. And as you do the other assignments for the class, basically your assignment 1, 2, 3, 4, 5 will be the only repositories that you see on here. But find your, you can find your repository that way and go back to it. Okay? So from this point, then I'm going to clone the repository like we did before. But here, when we're working on the assignments, you want to clone it using your SSH. So you use your SSH key pair in order to access this repository, which will allow you to make commits and push them back so I can see them and grade them. Okay, so I'll copy the SSH URL and go back and do a clone. So this time, this will be your first test that your SSH pair is set up correctly inside of VSCode, because we're going to clone now, but we're cloning using SSH. So it needs to have that public-private key pair set up for this clone to work correctly. So like we did before, select a directory locally to put your repository into. I'll put it into my repos, CS7 574. We'll select that as the destination. And we'll go ahead and open up that folder as my project. And this time, when it prompts me, again, since my Docker and my dev containers are set up, I should get this prompt, so I'll just reopen this folder in a container here. All right. So again, this could take some time, although the Docker is going to be using the same images for the container, so it shouldn't take you as long as the very first time if you already did the class resources, right? But it might take you longer than that than I just showed there. So. But again, also a Jupyter Lab server is running. Here, there's going to be two things that you're going to be putting code into. So you'll be putting code into like a IPython notebook, usually named something like assignment 1 for assignment 1, assignment 2 for assignment 2, something. And you'll also be modifying, adding code to the assignment task.py file that's in here. But let's go to the notebook first. I usually edit and run notebooks using the Jupyter Lab, although you can actually do them from VSCode. I won't show that today here. But yeah, like before, you can open up the NoHub file and scroll to the end to find that URL or that token that you need to log in to Jupyter Lab. I'll just control-click on that to get to my assignment 1. All right. So here, I'm going to just jump right into the assignment 1 notebook. Okay. So here's where you'll get all the instructions for what you need to do for the assignment. Okay. So for assignment 1, there's actually 4 tasks that you have to do. You have to write a Python function that uses recursion. Task 2 is about some NumPy operations. Task 3 is another function, but writing a vectorized function that does some plotting. And then task 4 is doing some stuff with pandas. Okay. So these notebooks, as I give them to you, should run cleanly. So that means that every cell, when you start the assignment, should run from top to bottom. You can check that out. I usually just use this on the toolbar here to restart the kernel and run all the cells from scratch. Okay, so this should be working. It'll run. It's running the Python from inside of your container, so it's using all the tools that we set up for you. You know, it's using NumPy and Matplotlib and Pandas that were installed in the container for you, the correct versions of all these. Now, the cells that are running these tests should run, although a lot of them will fail. So the cell actually runs, it's failing the tests here. Okay? So, like for task 1, you actually have to implement a function called test Fibonacci efficient. All right. And you'll see that there's an inefficient version that's already implemented, and these tests are actually passing. So if we go back and look in the assignment tasks in our source subdirectory, so I went back to VSCode, you'll see that there's a function implemented for you already, Fibonacci inefficient. That's the one that's being called for the test. So this implements finding the nth Fibonacci number. All right. Basically this is saying that all the test cases that we have defined are passing, whereas all the test cases for the efficient version are failing right now. Right? So yeah, your first task is really to implement this efficient version using memoization as is described here for the task. Okay, so I'm not going to show you how to actually do that, but I'm going to cheat a little bit. So for example, if we take the implementation, this is a common inefficient recursive implementation. So to calculate the nth Fibonacci number, we find the n-1 and the n-2 Fibonacci number, add those together to get the next one in the Fibonacci sequence. And we have 2 base cases for that. Right? But if you know how this works, because the tree, this recursion tree, explodes, so it can become very slow. So if you try to calculate the 40th Fibonacci number using this, it'll start taking a long, long time for numbers bigger than 35 or 40 or so. Right? So you're supposed to implement the Fibonacci efficient. You'll see that it's not doing anything. It's just returning 0. So you actually have to put your code right here. You can remove meta comments like this. I'm just going to put the inefficient version in here again, although I'm going to change it so it calls the correct one recursively. So it calls Fibonacci efficient. So notice, this is the Fibonacci efficient function. This is the Python documentation. This is known as the PyDoc string here that documents the parameters, the return value, and test cases and things. So if I do that, it should actually pass the test. So like if we run, let me do a restart kernel and clear all the output. Okay. And then let me run everything up above this cell right here, which is the one right before we try to test the efficient version that you're supposed to implement for this first task here. So I'll run all above this point here. So our inefficient still passes when it runs all these unit tests. So notice it took a little bit of time to do the 37th one. And if you tried to do 40, it would take more than a couple seconds. It would take 10, 20, 30 seconds or so. Or you could uncomment this if you wanted to try it out. I won't do that here. I'll talk about that in class maybe later. So what I was just trying to point out is that since we modified the efficient version, it should actually pass the test, although this is a cheat. It's not a correct implementation. You have to implement it so it's an efficient version that uses memoization instead of just a copy of the inefficient version. But if I do Shift-Enter, notice it runs the test, and they're all passing now. So that's the general thing you want to do. For each task, you want to implement it the way that's described and get these tests to pass. And again, if I ran this, it would take a long amount of time. I'm not going to show this here. I'm going to go ahead and comment that out and save my notebook here. All right. So then as a final thing, in order for me to actually grade it, you have to create a commit and push this back up to GitHub. So the way to do that, if you go back to VS Code, I recommend using the VS Code source control for creating commits and pushing them. This will be the first time that we test inside of the container that your secure shell key is set up correctly, got copied into the container, and is able to push commits back to the repository. Some people have problems sometimes that they can clone, but their keys don't get copied into the container. In fact, I'm not certain that mine got copied in correctly. I'm going to test it. So when I open a terminal here, it's actually running inside of a Docker container here. I can kind of tell from the prompt that that's the case. So it's running inside of this Docker container as this VS Code user. So if I authenticate, so this means that my key is correctly inside of the container. And if we look at my configuration, I should see my username and email got passed into here. The core auto carriage return line feed wasn't needed on this, but my username. So this might not get copied into your container. If it doesn't, you might have to create a new key inside of the container to get it to work. Or do something else. I can help you with that if you have an issue. So, but this should work for me. So we're going to add both of these files. So remember, so it's also useful to check what differences you made. So if I click on this in the source control, I can see that I modified the Fibonacci efficient to implement some code here. Okay, so it's not really an efficient implementation, but I did an implementation of this function. And you can actually get a diff of the notebooks in VS Code, so you can see that these cells change. So it's actually instead of failing, it's passing the test for that one particular cell. And I commented that out there. So, anyway, so let's add both of these files. So this is what's known as staging a commit. So we'll add them to our commit, and we'll do a commit message. Try and do a commit message that has at least a title. So task 1 implemented. So a title, then have a blank line, and then a couple one or more sentences of description. So we implemented task 1 by cheating. We copied the inefficient implementation to the function. So it is really still just an inefficient Fibonacci calculation. All right, talking about it doesn't have to be. I mean, I'm just trying to get you to get used to good Git practices. And good GitHub process. So the standard convention is you should have at least a title and a couple of sentences of description of each commit that you make. All right. So once you've staged some files to commit, to create a commit of, you have a good commit message. You can make a commit by hitting that commit button. At this point, your commit actually still hasn't gotten up to the repository. So I tell people to look down here at the status. So this down here at the bottom, this means that there are no commits on GitHub that I haven't pulled down yet, but there's one commit locally. It kind of says this here in the pop-up. There's one commit in my local system here that hasn't been pushed back up to my GitHub repository. Okay? So you can sync the changes. Sometimes this button doesn't show up. I don't know why. If you don't see the button, if you do have any commits that you haven't pushed yet, you can go down here and push the button here, and that will push or sync the commits up to GitHub. So let's push that. So once you do that, so as a final thing I'll show you, if you go back to your repository on GitHub, there should be what's known as a pull request. So if you look in the pull request, there'll be a pull request called the feedback pull request. This is where I gave you feedback on how you did on the assignment. But every time you push a commit, you should see the commit show up here in the feedback pull request. Okay, I encourage you to make a commit for at least each task. So don't do everything and just push it as one commit. So incrementally show me you doing your work by completing task 1 and pushing that work up, and then task 2. That's also good practice. but here also the last thing I'll point your attention to the workflow here. So we're actually running those same tests that you saw in the notebook here on GitHub. So if you open up the details here, there'll be a lot of stuff. It actually has to create that whole environment and install all the stuff. So when it installs the dependencies, there'll be a lot of stuff here. In fact, I think it's still doing it. So like it's done there. So now once it gets past that, it will actually run all those same tests that you see in your notebook. Okay. So you probably want to check this every time you push a commit. This will be the main thing I'll be looking at to see. So the first thing it always does is it checks that your notebook runs cleanly. So that means that every time you push an assignment notebook, all the cells should run cleanly. It shouldn't have an error in the middle of the notebook and not run all the cells. And then after it does that, all those separate tests inside the notebook will get run and tried here. So it's actually passing the tests for the inefficient version, which it already was doing when you started this assignment. But it's also passing the test for the efficient version, although, again, I would look at your code and I would see that even though you're passing the test, you wouldn't get full points or any points here because it's really just a copy of the inefficient version again. But it's still failing the task 2 and subsequent tests. All right, so these are all failing. And for that, since the notebook is running cleanly and we're passing the first 2 tests, we're getting like a 30 out of 70 at this point. All right. Okay, so that's all I wanted to show you on this video here. We'll get more details on that here this week as we talk about the specific assignment tasks and some other stuff. Okay, that's it. I'll see you guys later.